In this video, we will find out the rank of matrix using some of the examples. We will take some various matrices and try to find out the rank of that. And to start with, uh, for any given matrix, we can find the rank using two methods. One is using minor matrices and second one is echelon form. Okay, and in this video we will completely discuss about how to solve the rank using the minor matrices. For that I will be taking various examples like 2 into 2 matrix, 3 into 3 matrix, 3 into 4 matrix, and solve that. So first, let us know what is rank. Okay, rank is nothing but the number of in or columns in a matrix. So what do you mean by independent? For example, let us assume there is a matrix like A, B, C, D, E, F, G, H, I. Okay, and in this is the first row, and this is second row, and this is third row. And if A is equal to K times D, and B equal to K times E, C equal to K times F, or in simple ways, R2 equal to, R1 equal to K times R2. So here the row R1 is depending upon R2, and similarly if R1 equal to K R2 plus or minus, let's take another constant C R3. So here it is directly depending. Here also it is algebraically it is also depending on, R1 is depending on R2 and R3. So these are known as dependent rows. Okay, here R1 is the dependent row if it is in the form of either of these two conditions. In the similar way, it is applicable to any other rows or columns. So first, we will take a 2 into 2 matrix and try to solve the rank of that. So let's take, this is example number 1. So let's assume 1 3 5 9. This is our matrix. We need to find out the rank of that, and you need to always remember that this is 2 into 2 matrix. So for a n into n matrix, the rank of that particular matrix M is always less than or equal to n. For what? For n into n matrix. Okay, so the rank of this is always less than or equal to 2. And using minor matrices, so as we are following the method 1, what we need to do is, first thing we need to find out the determinant of this matrix 1 5 3 9. So what is the determinant of this matrix? 9 minus 15, that is equal to minus 6. So as the determinant of the major minor or the matrix itself is not equal to 0, the rank of this matrix is equal to 2. Okay, the rank of this matrix is equal to 2. So what happens if the matrix determinant is equal to 0? This is our second example. So let's take a matrix minus 5, 5, minus 7 and 7. Okay, so first we need to find what is the major minor in this. The matrix itself is the minor of itself, right? So we will find the determinant of the matrix itself. So here, if the determinant of the matrix is not equal to 0, then the rank of matrix is equal to its order. If it is n into n, its order. Or else, if the rank of matrix is equal to 0, we need to check the next small minor. For example, here the determinant is equal to minus 35 plus 35, that is equal to 0. Okay, so the rank of A is not equal to 2. because the determinant is equal to 0. Then the possible rank of A is always less than 2. Okay, now let's take this is 2 into 2 matrix. Okay, this is 2 into 2 matrix. Now next minor matrix is 1 into 1 matrix. So let's take any single element. Okay, and the determinant of any single element is not equal to 0. All right, so as the determinant of 1 into 1 matrix is not equal to 0, the rank of A is equal to 1. So if a matrix is not a null matrix, then always the rank exists for it, and the rank is equal to the least possible rank for non-null matrix is equal to 1. Okay, and this is our second example. Now let's see the third example. Now we will take a bigger matrix. Let's take the matrix 0, minus 1, 5, 2, 4, minus 6, 1, 1 and 5. Alright, this is our example number 3. Now this is a 3 into 3 matrix. Okay, the rank of matrix M is always less than or equal to 3 or n. So first we will find out the determinant of matrix. If the determinant of matrix is not equal to 0, then the rank of matrix is 3, or else we will go further for the minor matrices. I mean next small minor matrices. Like this is 3 into 3. Next we will go for 2 into 2 and check the determinant. And next we will go for 1 into 1 and check determinant. So let's find out the determinant of this matrix. So 0, minus 1, 5, 2, 4, minus 6, 1, 1, 5. So here the determinant of matrix is this will be 0 and this minus 1 plus 1, 20 plus 6, 26, and 26 plus 5 into 2 minus 2 minus 10. I mean, let's do it again. Minus plus 1 into 10 plus 6 minus 5 plus 5 into plus 5 into 2 minus 2 minus 2. So here the determinant is equal to 6, which is not equal to 0. So as the determinant of 3 into 3 matrix is not equal to 0, we can say that the rank of this particular matrix is equal to 3. Okay, so let's take the next problem. So here we will be taking 5, 3, 0, 1, 2, minus 4, minus 2, minus 4, 8. So as this is also a 3 into 3 matrix, the rank of A or M is always less than or equal to 3. So first we will find the determinant of this matrix, that is equal to 5 into 16, 5 into 16 minus 16 minus 3 into 8 minus 8 plus 0. So this is equal to 0. So the rank of A is always less than 3. Okay, the rank of is always less than 3. So if determinant of 3 into 3, the single major minor, here it is equal to 0. So rank of A definitely not equal to 3. So obviously the next possibility is the rank of A is always less than 3. Now we have checked for 3 into 3 minor. There is only one minor and we have completed that. Next we need to check for all the possible 2 into 2 minors. Okay, if at least one determinant of 2 into 2 matrix is not equal to 0, then we can say that the rank of the matrix is equal to 2. And if all the determinant of 2 into 2 minor matrices is equal to 0, then we need to check for 1 into 1 minor. So obviously 1 into 1 minor, as it is a non-zero or non-null matrix, the rank will be 1. So this is already verified. This is verified. So the determinant is of the single 3 into 3 matrix is equal to 0, and there is only one minor 3 into 3. Then we need to check for all the here I am writing the statement, all the 2 into 2 matrices, all the 2 into 2 minor matrices. If determinant of one or any, if determinant of any 2 into 2 matrix is not equal to 0, then rank is equal to 2. Then rank of particular matrix A is equal to 2. So for that, let me take any one matrix. So let me take this particular 2 into 2 matrix. Okay, obviously I can see that this is not equal to 0. So determinant of 5, 3, 1, 2, that equal to 5 to the 10 minus 3, that is equal to 7. So this is not equal to 0. So what is my condition? If determinant of any 2 into 2 matrix is not equal to 0, then rank of A is equal to n, where n is the order of matrix. So rank of this matrix A is equal to 2. So here you don't need to check for other 2 into 2 matrices, because any 2 into 2 matrix determinant not equal to 0 is the sufficient condition. For example, if we take this particular 2 into 2 matrix, okay, 2 minus 4 minus 4 8, so here this is equal to 0, right? So this is 0, but we cannot decide that rank of A is always rank of A is less than 2, because we need to check for all the 2 into 2 matrices. So what, so after checking for all the 2 into 2 matrices, we need to decide to go for lower order. So there is a problem in this. You may miss any 1 2 into 2 minor matrices. Okay, and for that it is always advisable to use the echelon form. Okay, there is no chance you can miss any minor, like there is no concept of minor itself. There we will do some elementary row operations, and that will be very easy to do, and we will be discussing that in the next video. Okay, and this is the fourth example. Now let's solve for another 3 into 4 matrix. So this is example number 5, and the matrix is like 1 2 minus 1 3 2 4 1 minus 2 3 6 3 minus 7. Okay, so this is a 3 into 4 matrix. So always remember that rank of particular matrix A of order m into n is always less than or equal to minimum of m comma n. Okay, so here it is a 3 into 4 matrix. So rank of this particular matrix 3 into 4 is always less than or equal to minimum of 3 comma 4, that is equal to 3. Okay, and rank of 3 into 4 is always less than or equal to 3. So we need to check for all the first thing is we don't need to check for the entire matrix, because the rank of A is always less than or equal to 3. So it is proven that we don't need to check for um, complete determinant of this matrix. So it is advisable to check for determinant of the minor. Okay, the first possible minor is, so as the rank is 3, we need to check for 3 into 3 first. Okay, so let's take the all the possible 3 into 3 matrices. So what are the possible things? So this is one matrix, okay, and this is one matrix, okay, and this is one matrix, and 1 minus 1 3, I mean I'm checking the rows, 1 minus 1 3, 1 2 minus 1, 1 2 3, okay, and this is another matrix. So there will be 4 third order minus 4 third order minors. Okay, so we need to check for these third order minors. So first let me check for determinant of minus 2 1 2 minus 1 2 4 1 3 6 3. Okay, so it's clear that 1 into 12 minus 6 minus 2 into 6 minus 3 minus 1 into 12 minus 12. So this will be 0 and this will be equal to 6 3 minus 6. Okay, and the first third order minor determinant is equal to 0. So we cannot decide that rank of A is less than 3. We need to check for all the possible things. Okay, and the second, we need to check for the second one, and the second one is 1 minus 1 3 2 1 minus 2 3 3 minus 7. Okay, now check for this, and this is equal to 0. Okay, and the second minor is also equal to 0. And let's check for the third minor, and the third minor is 1 2 3 2 4 minus 2 3 6 minus 7. Okay, so it is so I'm doing here 1 into 7 for minus 28 plus 12 minus 2 into minus 14 plus 6 plus 3 into 12 minus 12. This is equal to 0, and this is equal to minus 14 plus 6. This is equal to 16, and this is equal to minus 16, and this is also equal to 0. And let's finally check for the last minor, that is equal to this 2 minus 1 3 4 1 minus 2 6 3 7. Okay, let me do it in next slide here. The last one is 2 minus 1 3 4 1 minus 2 6 6 3 7. Okay, so here also rank of this is equal to 7 7 plus 6 plus 1 into 7 4 are 20 plus 12 plus 3 into 12 minus 2 into I'm very sorry, here it is minus 7 actually. So minus 7 minus 28, and the determinant of this is also equal to 0. Okay, and we have checked for all the possible 3 into 3 minors. Okay, and each and everything is equal to 0. All 3 into 3 minors determinant is equal to 0. So obviously rank of A is always less than 3. So now less than 3, what is the next possible minor? That is 2 into 2. Okay, we are checking for whether rank of A is equal to 2 or not. We need to check for this. So for that we need to find out the determinant of all the possible 2 into 2 matrices. Okay, so let's take any one 2 into 2 matrix. So let me take here itself. So this is also one of the 2 into 2 matrix. 2 minus 1 4 1. So that is equal to minus 2. I'm sorry, this is equal to 6. So this is not equal to 0. Alright, so if at least one particular minor order is not equal to 0, then we can decide the rank of that is equal to that particular order. So it's here 2 into 2 matrix rank determinant is not equal to 0. We can say that rank of this matrix A is equal to 2. So however, this is the long process. Yeah, this is one of the method, and in the next video we will discuss about the echelon form. Thank you.